Hey guys, the topic of this video today will be center of mass. Center of mass is the average point of the total mass of a system. And you may ask, what does that mean? And I'll answer by giving you the formula. Formula is m total, T for total, times x, center of mass. This is the position of the center of mass, equals m1 x1 plus m2 x2 plus all the way to uh, mn xn, and n is just a number, the amount um, of objects in the system. So if you want to find xcm, you do m1 x1 plus mnxn divided by mt can be written as m1 plus all the way to mn. And now that we know this, we can hop right into the question. Three spheres of radius r, 2r, and 3r are placed next to one another in contact with their centers along a straight line and the 2r sphere in the center. Where is the center of mass of the system? Assume the spheres are made out of the same uniform material. So this is a diagram of the system. See, there are three circles. It's not to scale though. And first of all, I'd like to talk about my experiences with this question. So when I was less experienced with center of mass, I thought that since you can draw a line through it, and the top and bottom are symmetrical, you can just cancel them out. So it would just be like uh, a one-dimensional problem, and then you just find the middle of all three spheres, which would be here. But if you think of it like you have a stick, then you have like a big rock on the end, or like a hammer, then you would think, where's the center of mass? Well, it is definitely not in the middle. It is closer to the head of the hammer. So don't make the same mistake I made. Don't simplify it into one dimension. So, doing the question, we're looking for x of center of mass. So xcm equals, take our formula from before, m1 x1 plus, and in this case there are three objects, so we have m2, m3, and m1, m2, and m3. Oh, whoops, 2 divided by m1 plus m2 plus m3. And you may ask, well, Morgan, we are not given m, so how can we solve this problem? Well, actually, there is a clever workaround for this, because we're given this hint, same uniform material. And in this question, we actually have to use density. And if you didn't know, density is mass over volume. So if we want to find mass, we know that it's um, density times volume. So since the density of all three are the same, we can substitute it in. All three spheres are the same. We can substitute it in dv1 x1 plus dv2 x2 plus dv3, I should do capital V to show its volume and not speed, x3 divided by dv1 plus dv2 plus dv3. And notice how every single term, top and bottom, has d, so that means we can cancel it out. And we're left with x center of mass equals v1 x1 plus v2 x2 plus v3 x3 divided by v1 plus v2 plus v3. Now all we need to do is find v. And if we look back on the question, we have 3 spheres. So we need to know the formula for volume of a sphere. And don't worry, I'll give it to you guys. It is 4 over 3 pi r cubed. So now we just need to substitute that in with the radius of each respective sphere. So v1 is 4 over 3 pi r cubed. The r stays the same, r cubed, yeah. And x1, we can also do that now. Let's say we also need to establish a reference point in this question. Now, since since on a graph, normally right is positive, left is negative, we can start by putting our 0 on the left of the smallest circle, so that going to the right, it goes positive. So if we say this is 0, that means the center of mass of the first sphere is 1r to the right of 0. So it is just r plus v2. v2 is 4 over 3 times pi, pi r cubed, and in this case it's 2r cubed, and then times x2. Count, there's 1r to the left. Here, let me zoom in. 1r here, 1r here, then there's 2r here, so that means there's a total of 4r to the center of mass of the second circle, times 4r. And then the third sphere, 4 over 3 pi, in this case it's, 3r, it's the radius, 3r cubed. And now let's count again. Here it is 4r, so plus another 2, 6. And to the center of this, there's another 3. So total it's 9 from the reference point times 9r. And then divide by the same thing at the top except without the center of mass. 4 over 3 pi r cubed plus 4 over 3 pi 2r cubed plus 4 over 3 pi 3r cubed. And now we can simplify this again. So notice how each term has 4 over 3, each term has pi, and each term also has at least r cubed. Well, actually, let's deal with that in another step. We can get rid of 4 over 3 pi from every question first, and that will simplify things quite a bit. So now we'll rewrite it without that. And we'll also put the r's together. So r to the 4 plus 2 cubed is 8 times 4 is 32 r to the 4 plus This one, 3 cubed is 27 times 9. That's the same as 3 to the 5. So 3 to the 3 is 27 times 3 is 81. 81 times 3 is 162 plus 81, 243. So this is 243 r to the 4. Then divide by r cubed plus 8. Oh, yeah. So plus 2 cubed is 8 times r cubed plus 3 cubed is 27. Oh, whoops. 27 r cubed. And now we can cancel out some r's. We have r cubed in all the bottom terms and r to the 4 in all the top terms. So we can get rid of the r cubes completely and then simplify the r to the 4 to just r. Then we're left with xcm equals r plus 32r plus 243r divided by, no, that's 1 plus 8 plus 27. And now we can add r plus 1 plus 32 is 33. 33 plus 243 is 276r. And then the bottom 1 plus 8 is 9. 9 plus 27 is 36. So now we can put this in our calculators and divide. And you should get 7.6 repeating times r. Now, in the book, it said 6.6 repeating r, but that's because they took the reference point to be at the center of the small circle. So it was 1 r shorter. And I just wanted to show that depending on your reference point, you can have different answers. So just because the number is different doesn't always mean that you got the wrong answer. And yeah, that's about it. Thank you for watching.